So thanks for the introduction. Well, you were mentioning size and weight of a car, but it's more size and price of a car, of the devices that we sell. But yeah, it's also heavy. So we actually, our clients are calling them high-tech robots, so that's why we keep this in. My name is Gerwin. I'm the CTO, which in the T is mostly technical, but most of the time tinkering. You will see from the slides what kind of tinkering we do. And Mathieu is our imaging engineer who ended up doing a lot of ServerSide.swift as a side job, but he seems to like it, so we're sticking to that. So, seeing all the talks here and talking to a lot of you guys yesterday during the boat trip and whatnot, we seem to be the odd one out. We are actually in the fashion business. Well, the fashion business is more technology-driven. Actually, e-commerce is a multi-billion-dollar market with an enormous demand for technology. Not only hosting all the stuff that you want to buy and all the process around it, but for us, it's also the enormous demand of content generation. So all these jackets that you see here, most of them are actually photographed. They're not rendered, although companies would like to. Most of them need to be photographed. So our company comes from, stems from a software company that works in that area, like the e-commerce and big fashion retail. And we saw the need for doing something to that enormous pressure of content generation. So we ended up building machines. Like we said, the size of a car, the price of a car, big steel constructions with photo cameras in it, computer in it, and lights, where companies can put those in their warehouses and start generating content. This is almost a factory flow, right? The garments come in out of a container, and you need to shoot them, because as long as they're not shot, as long as you don't have the photos, as long as you don't have the video, nor the metadata, you cannot put it online. You cannot buy it. And for these companies, it's the quick turnaround that's really important. So what we invested in is getting to know these companies' workflow, the kind of problems that they have in content generation, and we started building devices, experimental devices at first, but starting to streamline the whole experience of the content generation workflow. So these are the kind of brands, worldwide brands that we cater to. So they buy our machines. We don't provide the service for it. They buy the machine and they put the machine in their warehouse. And this year we'll be reaching over 1,000 installations all over the world. As our marketing team likes to call it, like every continent except Antarctica. And so this is where we install the machines and where we service them. And each machine actually is a big steel construction. Within it, a Mac, motors, lighting, and all kinds of additional electronics that we do. So the way that the users actually use a machine is not the traditional way of having a workstation in a warehouse. It's not a barcode scanner and a keyboard monitor interface. But all the way at the beginning, we started out with an iPad interface. People in the fashion and business are somehow fashionable, so they wanted to use the iPad to begin with, and actually it turned out to be a great device for them. Great to use, and it allows us to get the best interface experience in that workflow. Because when you're shooting content, you want to worry about your product. You don't want to worry about fiddling with the mouse and seeing what Adobe folder you need to select in, if you would use Photoshop, for example. So we started off with the machine all the way to your right, which is the style shoot horizontal, which is flat lay photography, a rather simplistic device, just to take stills, which would remove the background. Later on, we improved that system to include mannequin photography, which means you dress a mannequin like a dummy with a shirt. And as the market evolved away from stills, we also wanted to invest a lot in video. So that's actually where we started our journey, or I want to start the journey is from 2011 we started building these machines. So the first experiment was somewhere in 2010. But in 2011 I joined the company and I got to adopt all the software, which basically 3 USB drives saying, this is Objective-C. for the iOS part, this is the Java part from another freelance guy, and this is the C++ part. Good luck. Well, thank you. So we dabbled with that for a few years, and actually it was quite robust. So the way that works is we have an iOS application, written Objective-C, running on the iPad, which communicates through a REST API on a local network, on a local machine, and a Mac inside the computer, well, runs OS X at the time, and basically exposes the services of the machine, like the control of the camera, the control of the motors, through a web service written in Play, which is a Java web application framework. And on its turn, it would communicate internally through the file system and through socket communication to a C++ library that we wrote based on Qt. So that would take care of the camera control and the serial communication with motors, for example. But what we already experience in all of these adding features to the system is that we're continuously remodeling things on the C++ side. You would have to basically redo that on the Java side, and again do it on the Objective-C side. So a lot of reiterations on relatively simple things. And what we also noticed is that the REST API, like REST only, is a bit too cumbersome if you start to have more asynchronous events. Most of the time, our machines, the initial machines, were really sequential. So you take a shot, you just wait for it to be done, then you see the result, and then you continue. But like an interactive feedback from the server to show progress, for example, it was something that we were really missing. So we wanted to do something new there. But at the same time, we got, when traveling to photo conferences where we noticed that people started doing video more and more, right? Instagram was getting bigger, so people were posting more videos as well. And we thought, well, should we stick to the rather static stills of photos, or shall we continue? So we thought, okay, you know what? We want to build new machines that can do more than just static photos. So we want, instead of just doing photos, we also want video and more motion, almost like a full-fledged robot to put your product in, and it will take the shots for you. And while we're at it, why not do a new language on top of it? Because, hey, it's 2014 already, so we have this new thing called Swift, and we thought, well, that sounds like a solution to all our problems. Well, okay, so it sounds easy. Just do this, right? And actually, that's where we started. This was our dream scenario, and with the addition of WebSockets. WebSockets to get more interactivity, because if we're doing video, it's going to be a lot of asynchronicity in terms of processing. You don't want to keep the client in the blind or have it polling continuously to ask for progress. So here's where the tinkering comes in, because this is normally how we do a project. We do a lot of investigative spikes of like, okay, what technology do we need? So yeah, indeed, I saw you bouncing your head. That's Mathieu there in the top right, like cracking his head on this latest camera connection. And a lot of tinkering around new devices, like new motors. Actually, it was the time when Canon was about to release this new great professional camera, which is also exciting for us, and they let us in on this little secret that we were getting a new camera somewhere soon. I think it was when 1 month when you were in the office, joined, you unboxed that new camera. So a lot of excitement for us, and also a lot of experimentation, because what we sell is all in one studio, so we don't want to sell just the software. We also needed to experiment with light. So studio lighting, using custom LED panels is something that we need to experiment with the light to get the size right, to get the shape of the light right, diffusers, and how we control that from our software. So in addition, we started out with a lot of Cocoa apps, right? So we built a Cocoa app and, for example, used the Canon SDK to get used to the interactivity. Well, nice modeling, by the way. To get used to the interactivity and the asynchronicity of a camera, because you can shoot photos, you can live stream, but can you do it at the same time? Or once you record a video, how much transfer do you need to do? So it was a lot of investigation of how far we can push the camera on a single USB connection. At the same time, the same goes for motors, because we were used to just using one zoom motor, so we built this contraption with a slider going up and down, tilting the camera up and down, zooming in and out. and at the same time streaming our, at the time, professional model. Lucia is her name, because I got fed up with being behind the controls and being the model myself. So this started to get us also more grip on the asynchronicity of the motor behavior and HDMI streaming and this kind of things. So in the end, most of our work revolves around synchronizing motors, camera, animations, great animations, by the way, to make all ends meet, right? So there's a lot of components that are getting together, and we needed to have like a single level framework language to work with that. So of course, Apple on the Mac platform provides, and on iOS provides a lot of features, giving a core image, for example, AV Foundation, which allows color correction, all kinds of video editing procedures, and just the things that we would need. So we would augment that with our hardware control. And we even go beyond. We experiment with the 3D structure sensor, which is also selected because it was compatible with macOS. Did Swift wrapping around Objective-C libraries there. This is, for example, the camera cassette with a 3D printed hood for experimentation, a LED ring, you will see that in a minute, and a structure sensor to have like a one boxed components with motors, camera, and sensors all in one. So that's all nice tinkering, but of course the juicy part of why we're here is like it also needed a lot of tinkering in server-side Swift. It's a bit faking, right? We are basically, just like one of the previous presenters said, we had to serverify our Cocoa apps because we're going to host it to iPads and other devices later. So it's the choice of web framework, database, and serialization at the time, and this was early 2016 or end of 2015 a bit. So we're constantly thinking to ourselves, like, what technology are we going to choose? And at the time, it was basically these three. Right, Perfect, Vapor, and Kitura. And I think it's the requirement that we had at the time for doing WebSockets that basically, sorry, I had to do that, that left us with Perfect. So they were kind of feature part, and I think Vapor at the time was at version 0.5, I don't know, at the time, early 2016. So we ended up starting to experiment with Perfect. Actually, we played before with a small toolkit called Swifter, which is also really nice, like really small application, and an earlier Objective-C platform. It's called GDC Web Server, which was interesting because it also did socket services, like which we used in the past. But in the end, Perfect it was. And to make it even more odd, or at least in retrospect, we were looking for a quick and easy database, a sort of SQLite-like database, which provided us with a quick ORM. So we would model our structures in Swift, and we would basically have the database take care of of the storage of those objects. And combined with Object Mapper, also one of the solutions at the time, it was easy for us to write the models that we need, the data models that we need, have a small data storage extension, which would map the realm, and a small serialization extension, which would give us the JSON serialization and deserialization through Object Mapper. At the time, it was also CocoaPods. SPM was just being launched at the time, so we stuck to CocoaPods also because we wanted to launch most of these things, share the models, share the data models and serialization for iPads as well. So it was a year of dabbling in those kind of server technologies, but most of the time it was about all the juicy bits, at least for the consumer view, right? So HDMI encoding, exposure control, video cropping and whatnot. And at the same time, we had our iOS team. I think we were 3-4 people at the time who built this in the running of about a year. Basically focus on the representation on the iPad. So our composer is something where you guide the user through the whole process of recording videos, of taking stills. And again, we were quick in the iteration because we had shared models both on the server and on the iPad OS. So we'd be continuously updating our models. And So we started in 2016 with these first experiments, and in 2017 was time to show. This is at Euroshop in Germany, like the biggest, the world's biggest retail market, where we demonstrated our machines and also our new product. And we were literally coding up until the last moment until it was showtime. There was no hiding anymore. So that's where we actually announced the machine. And I think it's still a feature people still asking for is this top screen, which actually was a Apple TV syncing the iPad's display, just to have a quick view for people to see what was going on. It was really exciting times because we did a video shoot. You can see the big videos in the background. Those were the shoots that we did with our first machine, and we're really excited to show it. And I think it was a big success. Well, I never got the clear answer, but I think we sold out our first batch at the fair. So that was really nice. And there's a lot of tinkering going on, and it feels that it's tinkering, but we know, we've been through this process now 3 or 4 times, and we know that in the end we dot the I's, we cross the T's to make it into a really nice experience, right? This is the kind of videos that people would get if they would use it. And because of the workflow that we put a lot of focus on, they can create this content like day in, day out. It doesn't really matter who's there, there's no photographer involved anymore, but just a stylist. And according to the guidelines, say the presets that you selected, you can be quick in generating this kind of footage. So it involves, for us, we had to make the decision like how to stream the video, how to synchronize the motor movement, how to interact with the iPad at the time. And it turned out to be really nice, and clients actually love using the application. I think now we have over 100 machines in the field, and yeah, especially proud of what our team is now doing. So we have our own warehouse where we assemble the machines, we test the machines, and we ship them all over the world. So it's a nice story, say after for a year, and then a year of trying to catch up with all the bugs that we find in the field. But of course, there's been growing pains ever since, because we chose these platform. We chose the platform because we knew Swift was going somewhere, and Swift on the server was going somewhere. But of course, it was like, okay, perfect. Was that the great decision? I don't know. Well, I have my doubts now, and the same goes for Object Mapper, especially seeing all the involvement in the community here. So we've been thinking about refactoring, and also we need to refactor internally, and thinking how to modularize and how to select our new components. So one example or one challenge that we have is that we now have one part of the fleet, so to say, on Swift, and the other fleet is still kept the same, so we need to transition that as well. And at the same time, we've been playing with our server-side.swift, which basically means like, okay, we have one server and one iPad, and they collaborate. That's kind of easy, right? So it's in this machine, but we get more and more demands for factories like this. This is actually Zalando in Germany, with like an old train facility, like with these machines lined up, and they run production, that's for sure. So, but they also get these kind of questions like, okay, we have multiple machines on one installation, and we have another office again with multiple installations. So we get the questions of controlling the machines like remotely, or at least servicing them, getting the same presets everywhere so that the content that each factory generates is the same. And also more and more questions about third-party integrations. So it's inevitable that we go outside of our little confined box where we could say Swift is ready for production. Well, we tried, right? But now we're getting more outside of our little contained box. So we took a little bit of detour because we kind of felt like Swift on the server, like getting it into the big bad cloud. Is it ready? Well, the thing that I felt at least with like the batteries were not yet included. As the guys from Python like to say that Python has everything in it. For example, one of the services that we wanted to make is external integration with third-party processing services, which actually means they get our photos off the machine and have it sent to lower wage countries where like a fleet of Photoshop people would actually post-process the photos to make them look pristine, like clear up the labels, get out some wrinkles, or even simple things like Dropbox, which for us would mean like external services. So we experimented with this with Python on Amazon with the whole cloud system. And a similar thing happened with our service department, where they wanted to remotely service our machines, like preferably from the web browser. So we built also here a web-based app, which basically gives all the features that the iPad has and more. And we did that in Node.js and Angular because a young colleague joins the company, and we didn't want to have him dive full in the Swift ecosystem at once and also having to learn everything around it. So he played with Angular, which gives you a great head start. But of course, you're dragging all the Node.js both on the server and on the client with this case. So we've had this experiment going on for a year now, but I think for us it's we've been struggling in like how to continue this. Are we going to split even further? Or do we say, you know what, end of detour, it's time to get on the Swift highway again? But yeah, we know there's going to be construction ahead, and that's why I'm glad to be here and hear about your experiences and how to do all these things. And I think one of the realizations that we have is we rely so much on Swift, on Mac platform, that it's not going to be the same experience on Linux, especially considering the things that we do, right? Core animation, core graphics, like I'm not in, and I hear people here talking about foundation. Well, that's a basis. But for us, it's also all these other tools. So we have to see how we can split our services, maybe separate all the image-intensive stuff from the not-so-image-intensive stuff, and how to see if we can step away from the local monolith. So we're considering like XPC services to sort of split our application internally. Think about native virtualization, for example, VMware, to have parts of the services virtualized. But again, even VMware guest OS on a Mac OS, guest OS, doesn't support hardware acceleration. So this is a problem. So native bare metal hosting, for example, that Mac Stadium or xCloud provides, is an interesting thing. Or even, and that's where I'm hoping for, is native containerization. I guess Mac Stadium has just announced Orca, and they have told me that hardware acceleration, graphics hardware acceleration on native macOS platform is something on their roadmap. So I'm hoping for the best. But at the same time, we thought, okay, let's experiment beyond what we have today and more into the cloud. And this is where I transitioned to Mathieu and our lovely assistant, Lucia, who is going to help us more in the process.
Thank you. So yeah, the first thing we start doing is like a little experiment to see where we could go with a server. And well, we're using Slack internally, and from the support team, we got this nice dashboard and everything, but they always say, yeah, I need to connect to the machine, and it's like, and what happens if the connection to the machine is not working? How do I diagnose that? Is it my problem? Is it something else? So we made this one endpoint server that is like a Slack app, where they can just ask questions to the machine and say, okay, is my machine online? Is my machine having this kind of things? Can I run some diagnostic? Is there any outfits, like unexported stuff running there? Simple things that they can see, but just like summarize in one line. And that thing was really easy to do, like not say a couple of minutes, but a couple of days without ever doing this kind of things. And you could have had it, you cannot get it online right on Slack. It's really a personal thing hosted in a personal server, get full access to machines. But people start using it and start saying, okay, that's good. Then I think also we could extend that, because we internally in the lab, when we develop things, we sometimes run experiment at night during the weekend, things we probably shouldn't do, but okay. But there is no light, right? I mean, if you try to record a video in dark, you don't know if something is working or not. So we bought this fantastic, it's just a power supply, but you can turn on things with REST endpoint. And then we plug this to the Slack. So you can start, and also let your colleagues know, right? Okay, I turn on the machine, so you get lights in the lab. And I can make also Lucia start spinning, so there's something moving in the videos. And I record this all from my couch and something, and I just interrupt whenever I want. And we say, okay, that's one endpoint, that's one simple server, and it's like a great world of possibilities. So let's see what we can do from that. So I'm going to go a bit more into details about in-depth experiment we made, which is the event on the cloud. Like everyone, I think, we love to collect events about how the machines are used. Like, what are our users doing with that big machine? We always think like, this is the main flow, this is how they should use it. And then you get a request and people are in a state and you have no idea how they end up there or why they want to go there. So we say, okay, let's get some metrics about it. And so we can maybe help the UX team also to guide more people or design a new flow or add new feature because they may try to do something different. The only peculiarity in a way is like everything is controlled by the iPad. But the iPad is really like your remote control. You click on one button and a lot of things happen. Motors are moving, a camera is going into sync, send some HDMI signal, and then the video composition could arise, and it's stream and back and forth. So it could fail at many points. Many events are triggered by one click of a button. So we don't want to monitor what's going on the iPad alone. We want to monitor what's going on the machine. So the iPad is sending the event to the machine, and the machine is collecting these kind of things and sending multiple relevant events to a potential cloud where we collect them and we could later analyze them. So we set up a couple of requirements for that up front to say, okay, you've heard the story about the detour, and it's like, it ended up not so well, I would say, in the end. You have something, but it's hard to maintain. So this time we say, okay, pure Swift. So everyone in the team can just fix it if something happened, or extend it, or I have a new idea, I want to play. You can do it. You don't need to learn JavaScript or Node or whatever else, or even install it on your machine, which is already a big deal for me. That thing is sort of public also, not for public, but it's on internet, right? So everyone can access it. So it's like security has to be like first in line. So HTTPS, not an option. When you have only an iPad and a machine, everything is local, is in the warehouse, and sometimes you don't even have internet. Well, you can argue about HTTPS in that case. But there, it's like not an option. Let's also use the GWT for state-of-the-art tokens and authentication up front. And we want to save things into a beefier database, right? RAM was fine for a couple of things locally, but now it's going to be thousands of machines reporting into one server into the cloud. So let's get something a bit bigger, something we can really query and filter, and then we can present later with some sort of front end. Why not in Swift? I mean, if we can. I don't want to do especially HTML. So we select a completely different list of components for that. We've been through Kitura because there's like, it's almost battery included, I would say. So you get the logger, you get the cloud environment, which is really convenient to get your variable. You get your metrics, you can do a lot of things. You get this really nice also integration with the request for the database and a couple of different databases. You have security libraries, although you have to do quite a few things yourself, but it's there. You can do it. That was really convenient. You got a stencil for front end, so you can like show a web page really quickly, served by your server. It's not meant for production, but it's more like, you want to see if you get something, and sometimes it's convenient to have a little bit of UI around it, or pure Swift with Box and Martlet, which have been really fun to do. But in the end, we knew that that thing is going to be potentially used by another completely unrelated front end, like someone else making a pure JavaScript or Angular or whatever else. And they can just query your backend and make this state of the art. So documentation has been also set as like a high priority. We want to have something, a way to exchange. So Open API was the way to go for that. Because you can see everything. It's a really simple format, but you can get everything, and you can send it to someone else and say, okay, this is my thing, right? This is how you get the stuff, and make it pretty. So by doing that, we found a couple of slightly missing components, just like to showcase a bit. So we say, okay, this is missing, no worries, make a PR, move on. Super nice, super quick community. So, hey, in Kitura 2.9, sorry, I was too excited. It's in 2.9. I was super happy. It's like, great. So now I don't have to use a master branch or my own version. I can just use, again, the main trunk, and I was super happy. I mean, it looks silly, but having from day one, a complete documentation of all your endpoints without thinking about it, that was great. Okay. Oh, yeah. Sorry, I messed up a bit the animation. So now we had that application, and we built it for the cloud, communicate with the database. It's like normal backend things. If you're not an iOS developer, it's something you're doing every day, and it's really common, and that's great. But we made that in Swift, so we realized, like, okay, well, you know what? We can also put that in the Mac. Why? Because maybe you don't have internet at that time, right? You could experience a disruption, you could have problems, you could have latency. Well, that app is your fail-safe. So the core, which in that case point to the machine itself, right? Let's not make it communicate with the cloud and deal with all the problems we have. Let's literally run the same app on the machine itself, which is always there, which is always available, which has no latency unless nothing is working, but then in that case, well, who cares? And we collect event here. We save it into a database. To make it a bit simpler, we don't install PostgreSQL and all the data on all the machines in the field, especially because we just think about it, and it was like already 1,000 installation to do remotely, which is like, yeah. But you save things. You get an event, save it into the database, and then you send it to the cloud if you can, or you wait until you get internet. And if you get like some policy from companies say, okay, no, I don't want a low HTTPS outside of my warehouse for security reason. Well, it's the database. You can go through SSH or whatever other way that they allow, grab that database and update your cloud statistics. So it's always there. It's always available, which is really convenient. How it's going to work with that kind of things? Well, then, if you just had the iPad into the story, the user is clicking on something, doing an action, that communicates only with the core. And then the core is only communicating with the local server and saving things into the local database, retrying if you cannot reach the cloud. And if you can, you send it. Well, you may also want to keep them a bit, just in case something goes wrong on the cloud. But later, you get like this small database locally, last event, could eventually also serve it for a local perspective. You are a client and say, oh, how many shots did I took last week or last day or whatever? You have this information immediately. You don't necessarily need to go to the cloud. And again, I highlight that, but it's just the beauty of this full stack Swift, right? You make one app, and I just had one connection to pass through that thing, but it's just a single request, right? You get something and you send it to the cloud, and you have your fail-safe locally, and you have your server on the cloud, and you get full-fledged all the features without much trouble. So that was the part on the Mac. Now let's focus a bit more about how do we deploy that. I must have said that in the disclaimer, but you already told it a bit. I'm not a cloud developer, so basically it was probably my first app into the cloud, really. So I say, okay, let's go to something that is like, I know it's there, it's easy. We select IBM for the native support of Swift. It was like, I love using command line. I'm one of the subscriber of the, I shouldn't say that, but the Linux team. So command line, push your app, you get it, you run, it's perfect. I would also highlight the Devops tools, which were really, really great for me, because when I was experimenting, I keep pushing new app. So you took down your server, push a new app, by the time it's there, and then you continue. I didn't have millions of machines back in the days, but I need to have a couple of relevant stuff. So I installed these app into the showroom we have around the world, and they were pushing at random time. So I started losing event and get less information. It was painful. So with this simple thing, I could just like swap the app automatically. I mean, it could actually swap the app automatically for me. No downtime, always there, not to think about it. Same for Cloud Foundry. It was like immediately there. Well, we could have scaled to Kubernetes, or maybe it's what we're gonna do later, but having that there, when I need to scale, because I made this fantastic front end for debug that you're gonna see just after, but I get some peak of activity, and all of a sudden it's like doubling my RAM needed because my JavaScript skills are so over the top. And then couldn't get events also. So I just say, okay, well, if you get this kind of things, just auto scale. And if you pass the threshold, just spawn a new instance and keep running. And if you go down, just turn it down. This was really great for us. Allow us to have this app really in production without thinking about production, almost. That's the famous debug frontend I made. It's like collecting a lot of data and organizing things. So it's not super user-friendly, but it really serves the point. You just request database, get everything, and transform into some JavaScript, make some graphics connection and whatnot. And hopefully this can help later the UX users say, okay, well, I see like the size of the bulbs, it's really the number of events. So, and you get connection between, oh, that event and then that thing later, kind of connection. But probably in production, since we have a a real team, it's going to look like that. And this is basically, this is Angular? No, it's not Angular. It's well, some JavaScript front-end thing that we serve from the Kitura server. Sure, everyone rest assured, like in production, we're probably going to split these things and not make the thing getting events crash because of JavaScript, but it is there immediately, right? You get someone, I don't know, you can get a third party, you can get contractors making a website, looking great, having all the features you want. You're just giving the documentation, it's making all the things for you, and you can serve it immediately. This was like a really good realization. Okay, so to conclude a bit that talk, it's like we face a couple of issues, and most of them were around security. How do you ensure that what you're doing is really safe when you start opening more and more to the world? So we try to be state-of-the-art in GWT, using electric and all these things. We need to hash password. I mean, everyone knows you don't save a plain password in database. I knew that, but it's like, oh yeah, wait a second, how I do that? What's the good way of doing that? I'm sure that it's like 2 minutes for anyone to revert my hashing, or it's question like that you need to ask yourself all the time. And that thing is a bit like the batteries are not completely included, right? I would love to have a module that just say, you know what, hash my password. I want them safe. I don't want to think about it. Well, I write one. I hope it's going to be good enough. We have to install HTTP certificates. Not a big deal, but well, you know, first time it's always a bit funny. We have to prevent about SQL injection, and one of my, it's personal remark, but when you go through the tutorials and all these things with the Swift query, you know how you get the things and you inject your parameters and it's great. And then if you keep scrolling down, it's like, be careful, there could be SQL injection. It's like, oh yeah, maybe we should revert that. Start and say, okay, you should do that with the parameters and forget about the wrong way of doing it, because you probably have to go back to all your things and make sure it is there. Well, you can restrict your API, but it's more cloud things like one endpoint, a couple of things. We use databases and the ORM, which is good because it's up and running immediately, but you have a lot of limitations, right? So maybe next time if I have to redo it, I will do a bit more manual stuff because it's not that difficult, and you can maintain or try to... My mind is not completely set with that. It was great to have 2 databases, 2 use cases, and being able to use them, really, but you know, and it's like the last one is like, are we still following best practices? Well, all the one I could find, for sure. How do we overcome a bit this thing? And it's going to be like your takeaway. It's like codable. I mean, we have been through Object Mapper before. It's like codable is not perfect. We can all agree on that, but it's so much better and so easier. You get everything. You get your route. You get your documentation. You can share that model with iPad, Core, any third-party application you made also in Swift that is a server or not. It's really great. We also leverage a lot Package Manager. Due to the fact that it works on Linux and Windows, macOS, sorry, it was really great for that. Again, missing a couple of components to completely merge the old pipeline into Package Manager, but I wouldn't restart a project with Cocoa Pod if I can avoid it. The documentation is really the key. I mean, if there's one takeaway, it's like, thanks to all these things before, you get documentation, and it was like, I mean, no one loves writing documentation, as far as I know. I don't, at least. So this was really easy, and I could communicate with other people with different background, with everything, by just a simple page. And you can, I should have put a screenshot, but you can also see that in your server, right? And you can test it, and you can send the request from the web page. It makes your life way, way much easier. And the last point is like the more you're in the cloud, the more native, the better it is. I was really interested about the initiative from Amazon. It's like getting something really like native into your cloud, seeing the experience we had before with AWS and after with IBM, it's a world of difference. It is made for that. So Swift is there. I'm thinking, why not serverless in Swift? Because, you know, it's already there. It's really convenient. So I think that's about it about that. I can hand you over the clicker.
Yeah, thanks. Well, there's one thing remaining. So, of course, we're here because we like to see what's happening here in the community, but also I think it's a good platform for us to tell us that we're hiring flashy animation. So we're based in Haarlem, close to Amsterdam in the Netherlands. small team. I think we're now 7 or 8 developers. So we know the Swift on the server is a bit under construction, and it's not completely there yet, but we're willing to take the jump, and we're going to take the jump. So I would love to invite any of you who are interested to apply, and if you have any of these backgrounds, we would be definitely interested in talking to you, or regardless of your background. So you can scan this to get immediately to that same hiring page, or reach out to me directly after the talk, or on Twitter or whatnot. Thank you for your attention, and I hope it was a nice show.